Okay, for this question here, I'm going to follow the steps on page 281 because that's a very similar type of question. So the first things first, we are looking at the rate of decay of the mass of a radioactive substance is proportional to the mass of the substance present. So dm by dt equals some constant, and it will be decaying, so I'll put negative k, times m, the actual mass. So we then end up with negative 1 over km dm equals dt, integrating both sides. So we can see that Ln I'm going to follow what's in the book, so I'm actually going to cross that k out there and leave the k here on this side, and I'll leave the negative k on this side because I'm following that particular thing. So I've got Ln x, or rather our m, and we've got a constant, so we better add the constant of integration in. So we're going to have Cm equals negative kt. So now we can see that e to the negative kt equals Cm. So m equals that, and we substitute in 1 over c for a. Let's change the name for convenience. So we have got that there. Now, when t equals 0, we know that the mass equals 200. So 200 equals a e to the 0, and e to the 0 is 1. So a equals 200. So we've got the mass equals 200 e to the negative kt. Now we know, when we go back to our question, we could see that when the t equaled however many years, when t equals 2 years, mass equals 150, and we're asked for 3 years. So we're going to sub in the 150 equals 200 e to the negative k times 2, and so we're going to solve for k, which we should be able to do quite nicely. So if we take the log of both sides, we get log 150 equals 150 over 200, divided by 200 first, equals log of e to the negative k2, which of course means that negative 2k equals the natural log of 150 over 200. So k equals, let's get my calculator out, menu, execute, natural log 150 divided by 200, and then I need to divide that by negative 2, so I get a k of 0.144. Let's do that. 0.144, maybe not quite enough dp's. Now I need to plug in when t is 3. Oh. So now I've got t equals 3 years, and I've got m equals that. M equals 200 e to the negative 0.144 times 3. So m equals, oh dear, menu, execute, 200 times e to the power of negative 0.144, and I've got 173.2. So I've got that as my milligrams answer. Okay, if I put the right thing in the calculator, and just to be, so I actually put the wrong thing in the calculator there. So here I have my calculator with 200 to the power of 200 times e to the power of our negative 144, or more accurately that, times 3. Then I actually do get my 129.9 milligrams. It's been a long day.